Hey friends, welcome back. In this video we'll be assembling the DBB and output board for the SCELBI 8B, and if for those that don't know, we've been assembling the SCELBI computer right here in the last few videos. And so far we got the backplane installed, of course we got the underneath assembled, all the wires and everything, but we also got all, I guess we got two of the boards assembled, so the front panel board and the CPU board, which we had to tune in the previous video. And in this video we'll be assembling the DBB and output board. And it's a pretty basic board, there's not much to it. And you can read a little bit more about it in the SCELBI manual. Let me just go to that page. It should be on the last few pages of the manual. Unfortunately, again, this manual doesn't have any page numbers, but it has a title of the SCELBI 1101 DBB and output board, output card, and it kind of tells you some power requirements. So this one requires 650 milliamps of power. We're going to actually insert a 1 amp fuse into it, and it tells you how the data is buffered into the ICs here, and then strobed for the output. So if you want to read about it, you can read about it here. The next page here is the schematic for it, and again, it's pretty basic. And the next page is the parts list. We got all the parts right here. I got I think there's like 54 1K resistors that we have to install. That's probably going to be the most time-consuming part. And that's pretty much it. So there's actually one thing that I wanted to mention about this board, and that, first of all, there is a jumper right here that needs to be installed. And I think the original board is actually installed a jumper, if I'm not mistaken, here. According to the schematic, that should have been a trace there. So I actually went ahead, instead of us installing a jumper there, I actually went ahead and added a trace here for that. That's a positive 5 volt trace. Additionally, there is another area on the PCB, and it's basically right here, these resistors here, 4 resistors, and they're sort of tied all together here on a positive 5 volt plane here, and also I think there's a capacitor here. But this entire trace here, if you look on the bottom here, you can see that they're all connected together there, and it actually goes down to the capacitor as well. They're all connected together here, but that's pretty much it. They don't. This is supposed to be a positive 5 volt trace here, but it's not connected to positive 5 volts. And I actually looked at the original boards, and I did not see any jumpers to positive 5 volts. And I think Mike mentioned at one point that he also looked at the boards. Mike Wilgel, that is. He built a SCELBI computer as well. He mentioned that he looked at the boards, and this trace wasn't actually connected to anything. So I think this is a bug, because based on the schematic, it actually needs to be connected to positive 5 volts, but on the boards, it's not connected. So maybe it's a bug, but it's not a consequential bug, meaning that it just, basically there might be some floating voltages around there, which is actually making it work okay. But just to be safe, I think it might be a good idea to go ahead and tie this to positive 5 volts. So I'm gonna run a jumper wires from this trace here to positive 5 volts when we get to it. Alright, so on this page here, which comes right after the CPU details, this is the clock circuitry diagram, and right after that is the installation instructions for the DBB and output card. As usual, we'll try to follow these installation instructions as outlined here, sort of to how it is outlined here. But since we're not installing integrated circuits, but we're installing actually these IC sockets right here, we will install the resistors first, and then the IC sockets. Well, actually diodes and then IC sockets probably. And yeah, it's not much. There's not much to it. Actually, on the parts layout, which I'm gonna actually go ahead and take out of this binder while we assemble the board, I actually went ahead and drew the trace here that we just talked about on this board, and it says positive 5 volt net not connected on original. So the PCB is not connected, but the schematic actually is connected to positive 5 volts. All right, so let's go ahead and start the assembly. And as usual, I'm going to start with the resistors. And just before we actually start the assembly, I just want to let you know that I still do have a couple of these SCELBI 8B PCB sets available for sale at calensure.com. And I think maybe like just a couple of more of the front panels for the SCELBI computer right over here. I didn't have that many to start with, but there's maybe like, I haven't checked that yet, but maybe like 1 or 2 left. Yeah, so if you want to build the SCELBI computer, they're still available. There's also boards available for the peripherals, like the audio cassette input and output cards or boards, keyboard input board, and also a TTY interface board. Okay, let's go ahead and start the assembly. And again, there's 54 1K resistors that need to be installed, and it's just 1K resistors, and that's it. So let me go ahead and get to it. I also ended up installing the Zener diode, and this Zener diode that I have is the leads for this diode are kind of bigger than I expected, so I had to drill the pads out for the diode a little bit, but it wasn't too bad. All right, so we got the resistors installed and a diode. I think we'll go ahead and install the IC sockets next. And I think, yeah, so we have like 8 16-pin sockets and maybe 10 14-pin sockets. I'm going to start with the 16-pin sockets as usual, just so we don't accidentally insert a 14-pin socket into a 16-socket footprint. So let's go ahead and get started on that. Yeah, that looks good. We'll leave these plates in for now until we start inserting the ICs, just so we don't bend any of these pins. Let's install the fuse holder next. And again, these these need to be installed a certain direction. As you can see, one side actually has like an edge, I guess, to it. So we want to make sure that that edge actually faces outside, away from the fuse, and not inside to the fuse. Otherwise the fuse won't fit. I guess the last part are the capacitors here, and I'll start with the electrolytic capacitor. I think the positive side is on this side, and we don't have a positive like a plus sign on the PCB, so we just have to go off of this layout here, and the positive is actually facing to the right. I just want to make sure that this will fit in here. I guess we just have to bend these leads right against the body of the capacitor. And actually this capacitor might not actually fit. Let me just double check. These pins might be too thick to fit through the footprint. But if they are, I'll just drill it out. But you know, I think it should fit. It's the same capacitor as the other boards as well, so I think we should be okay. Yeah, it's sliding in there slowly. And also the these ceramic capacitors. Now we can insert the ICs. First we got to remove these plates, so let me remove these plates first. Okay, I got the ICs inserted as well. Just gotta make sure that none of the pins are bent, and also that all the ICs are installed in the right location and the right orientation. I think all of them are actually facing away from the edge connector here, so that makes it a little bit easier to insert them. But I think it looks good on my side. Alright, so there's one more thing that's left to do, and I'm not sure if it's mandatory or not, but I think we need to run a jumper wire from this positive 5 volt trace here that connects all of these here together, and the schematic also connects it to positive 5 volts, but it's not connected here on the PCB. So I'm going to go ahead and run some like a jumper wire from this trace here to a positive 5 volt trace nearby. I got this jumper wire here, and I've decided to actually run it from here to this trace right here. I think that should be the positive 5 volt trace, and we can probably trace it to positive 5 volts if we wanted to. Let's see. Positive 5 volts runs there, and then here. Yeah, so I think it is positive 5 volts, so let me go ahead and solder it in, and I'll just kind of solder it, surface solder, I guess, it directly to the trace. Alright, I think that looks pretty good. And let me use my continuity meter just to kind of confirm that it's actually connected to positive 5 volts. So I'll just put one probe here and the other one on the positive 5 volt line, which should be right here. Yeah, so yep. So I think we're good. Alright, so I guess there isn't much that we can do with this. Like, we can't really test it right now because we need the computer to test it. So I guess I can go ahead and insert it into the SCELBI computer. And we can probably power it on as well, just to kind of do a literal smoke test, but there isn't really much that we can test with it just yet. Well, it's working, so that's good. Yeah, the CPU is still functioning, so that's good too. And I'm not seeing any smoke just yet, at least. So yeah, I guess this is as far as we can test it. Alright, I guess that'll be it for this video. So we assembled the DBB and output board here. In the next video, we'll actually assemble the next board, and that's the input board. And that would be maybe like half of the boards already. Actually, I think we're halfway there now, but I guess when we add another one, it depends on, I guess, on how many of these RAM boards that we assemble. So yeah, in the next video we'll be assembling the input board. Don't forget to subscribe if you haven't already, and don't forget to click the like button as well if you enjoy watching this video, and I'll see you in the next video.